Okay, now for the function we've been using, I'm not going to read it to you. It forms a helix, okay? And we know from long experience that this much of it describes a circle of period 2 pi in the xy plane, right? And then it's not 3k, it's 3tk. 3tk means that we're also rising at 3 units of z per unit of t, right? So, actually I called this 3. I'm doing 2 pi. I don't really totally like this, but I'm sorry, go ahead.
He's a bit cold.
Again?
He's talking about how he's a little bit cold.
Yeah, I got chilly this morning. What is this? You know, we're still in, we haven't had any cool weather in September, and we're 2/3 of the way through the month, right? Fall starts like tomorrow, right? It's been humid and hot. Not totally hot, but the humidity's been something. So it was kind of pleasant to be freezing my butt off this morning. Okay. Okay, this picture isn't quite to scale. 6 pi would be a lot higher. It'd be like near 20, right? 5 times as high as this would be way up there. So kind of squashing down my z-scale. So kind of keep that in mind. But see, down here in the plane, we've got a circular path, right? And we're just moving above this circular path on a cylinder. So as we go around the circle, we're rising at a certain speed on that cylinder, right? So by the time we get here, we're 1/4 this high. So I'll just kind of mark a point here. And here we're going to be half this high, so we're going to be up here. And when we get over here, we're 3/4 of that height, so we're going to be like here. And when we get here, we're going to be all the way at this height, so we're going to have a point here, right? And then we're going around a circle, so our path is going to look much like this. And there's some subtleties to this path that I'm totally incapable of representing. And then it comes back up to here, okay? Because of our perspective, this is the way it looks. I should have tilted the x-axis a little less. Maybe I should have been a little more accurate with some of this, but there it is, okay? That can't be right. Actually, you get this kind of retrograde picture where it kind of does this and then comes around like this. So I, again, chose a bad value of t, so I'm going to change it to pi. I don't want to try to draw the picture here. The way the picture looks from here to here is kind of I don't want to go to the trouble of trying to draw that, okay? There's kind of a little kink in the thing from this angle. Because you're looking almost parallel to the loop when it gets here. From this perspective, we don't want to deal with that, so we're going to go here. Now, my point is that, okay, here you've got a unit tangent vector and a unit normal vector. Okay? Unit normal vector is not back toward the origin, but it is toward the z-axis. But the unit tangent vector, you're climbing, right? So we've got our unit tangent vector. I'll kind of exaggerate its vertical component. We have a unit normal, and then we have our binormal that we can easily calculate. Okay? And we want to work within that coordinate system because our osculating circle will be in the plane defined by t and m. Okay? So the osculating circle is in the plane through the point So what's the point? X is -1, y is 0, and z is 3 pi, right? And that is this point. There's our coordinate system. That's temporarily the coordinate system in which we're moving, right? Now, as we go around a little further, of course, you know, the t and n are going to change direction. And this thing's going to rotate. And so the binormal's going to change. Okay? So we get a little of that. So there's our osculating circle of plane through this point. There's our plane through the point. At least that's a plane in which our osculating circle will be. In the radius, reciprocal of the curvature, but we haven't defined curvature. I'm just going to say the curvature of the osculating circle it's the same as the curvature of our path. Okay? Now we need to digress a little bit and define curvature. Okay, well, we want to build that up intuitively and then make it rigorous, okay?